A football is thrown from the ground with an initial velocity of 15 meters per second at an angle of 35 degrees. So I set up a triangle with the degree of 35, and the initial velocity goes at the hypotenuse. So now I need to find the components of x and y. So first I'll find x using cosine, which would be cosine 35 equals x over 15, or 15 cosine 35 equals which equals 12.29. And then for y, I can do sine, so sine 35 equals y over 15, because it's opposite over hypotenuse, and that would be 15 sine 35.
So like, if you need to pick cards, you need to have...
Which is 8.6.
You need to get a flush. Okay.
So VIY equals 8.6 and VIX equals 12.9. And I'll find the range first so I can plug those in. So VI of x is 12.29 and VIY is 8.6. And using that, and the acceleration in the x is 0, so the initial and final velocity are the same. And I know that the acceleration in y is negative 9.8 meters per second squared, and this is meters per second, these are all meters per second. And I know that that is negative 9.8 meters per second squared because that's gravity. And I also know that the displacement in y is 0 because it's going up and down, so there's no y displacement. So now I can use this chart to solve for time. So I will use equation number 3, which is change in d equals VIT plus 1/2 AT squared. So you have 0 equals 8.6 time plus 1/2 0, or whoops, equals negative 9.8 t squared, and I can put that into my quadratic formula program on my calculator. So I have negative 4.9 8.6 and 0, and my answer is time equals 1.76 seconds, and I can plug that in for x and y. And then I can use this to solve for the change in d, which is what I'm looking for range. Use equation 3 again, this time for x, so it's delta d equals VIT plus 1/2 AT squared. So I have change in d equals 12.29 times the time, which is 1.76, and this can all be crossed out because a is 0. So for that I get 21.63, and that is my range. So that's meters. So next I'm going to solve for height, which I can fill in. I filled in already the VI and VF from my triangle, and the acceleration is going to be 0, and the VF is going to be 0, and my gravity is the acceleration in y, so that's negative 9.8. And what I'm solving for now is the change in d in the y direction, because that's the max height. So I can use equation number 4, which is VF squared equals VI squared plus 2AD. So that's 0 equals 8.6 squared plus 2, negative 9.8, change in d. I'm solving this equation, and I have it plugged into my calculator, and I do negative or positive 19.6 change in d equals 73.96. I divide 73.96 by 19.6, and my answer is change in d equals 3.77 meters.